Our new unit is going to be on trig identities. An identity is an equation that is always true no matter what your variable is. So for example, a squared minus b squared equals a plus b minus b. This is an identity because no matter what you put in for a and b, this will always be true. And this is something that you might remember from our very first unit. This is the difference of squares formula. And so today we're going to be learning a bunch of trig identities that we can use as substitute in to be able to simplify an expression. So let's really quickly just review our 6 trig functions. So on the unit circle, our radius is always 1. So we're just going to put in 1 for r. So if r is 1, our sine is just y, cosine is just x, and tangent is still y over x. Our cosecant is the reciprocal of sine, so we have 1 over y. Secant is the reciprocal of cosine, and tangent is the reciprocal of cotangent. So just a review of those are our 6 trig functions. And the equation of a circle is x squared plus y squared equals 1, and this is actually where some of our identities are going to come from. So our first couple of identities are just using the reciprocals. So because cosecant is the reciprocal of sine, we can write cosecant of theta as 1 over sine of theta. Secant is the reciprocal of cosine, so we can rewrite secant as 1 over cosine. And then cotangent we can rewrite as 1 over tangent. So our first 3 identities are just the reciprocals. Our next 2 identities are going to come from the ratios. So because tangent is y over x, sine is y, cosine is x, so we can actually rewrite tangent as sine over cosine. And because cotangent is the reciprocal of tangent, I can write cotangent as cosine over sine because I just flipped it. So these are our first 5, 1, 2, 3, 4, 5 identities that we are going to use to simplify expressions. Now notice that with these identities, we can square any of these identities and they will still hold. So for example, tangent is sine over cosine, which means tangent squared is sine squared over cosine squared. So this is still an identity, it's still true. Cosecant is 1 over sine, and if we square cosecant, it would be 1 over sine squared. So it's still true as long as you square everything in that identity. Now we're going to have 3 Pythagorean identities. These are called Pythagorean identities because they come from the equation of our circle, x squared plus y squared equals 1. Now the 3 identities that we are going to need to know for the Pythagorean identities, our first one is x and y are sine and cosine, and so because x squared plus y squared equals 1, we know that sine squared plus cosine squared is also always going to equal 1. The next identity that comes from this is 1 plus tangent squared equals secant squared. Now the reason this one holds is if you divide all of these by cosine, it will give us this equation right here. So it's not really important that you know how it's gotten, you just need to know these 3 identities. Okay, so then our next one is if you divide all 3 of these by sine squared, we end up with 1 plus cotangent squared equals cosecant squared. So these 3 identities, along with our reciprocal and ratio identities, are what we are going to be using all of this unit to simplify expressions. So a note that comes with these expressions, or these identities, we can also move terms around to create new identities. So for example, with sine squared plus cosine squared equals 1, I could subtract cosine squared from both sides and get sine squared equals 1 minus cosine squared. Right. I could also, starting off with this identity, instead subtract sine squared from both sides and end up with cosine squared equals 1 minus sine squared. So I can move terms around to get new identities. So same thing with our second identity. With this one I could subtract tangent from both sides and get 1 equals secant squared minus tangent squared. Or I could subtract 1 from both sides and get tangent squared equals secant squared minus 1. Right, so all three of these are saying the same thing, they're just in different order. So same thing for our last one. If I subtracted cotangent squared from both sides, I would get 1 equals cosecant squared minus cotangent squared. If instead I subtracted 1 from both sides, I would get cotangent squared equals cosecant squared minus 1. So all of these identities mean the same thing. This is just showing you that we could take one of them and move terms around, and it'll still give us an equation that holds. Okay, so now we're going to see what we are going to do with these identities. So flip the page. First I'm going to summarize in a chart all of the 8 identities that you need to know. So our first ones are our reciprocal identities. So we know cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. And then our ratio identities, tangent is sine over cosine, which means our cotangent, if you flip it, gives you cosine over sine. And then the 3 Pythagorean identities, we have sine squared plus cosine squared equals 1. We have 1 plus tangent squared equals secant squared. And then 1 plus cotangent squared equals cosecant squared. So with these 8 identities, we are going to solve and simplify a whole bunch of different expressions. So we are going to be using this for the next 2 weeks. Okay, so let's see the type of problem that you're going to be solving. So what we're going to do today is just simplify each of these expressions to a single trig function or number. So that means our final answer should just be either one trig function or a number. So let's look at number 1. This is sine of theta times cotangent of theta. So the identity that we're going to use here, we know that cotangent is cosine over sine. It's also 1 over tangent, but I'm going to use cosine over sine because this one has a sine right here. So if I replace cotangent with cosine over sine, because cotangent is the same thing as cosine over sine, I'm going to turn sine into sine over 1. Now I can simplify this because there's a sine on top and on bottom. They can cancel out. And this just leaves us with cosine over 1. So this is just cosine. Okay, so let's take a look at number 2. So we have sine squared over cosine times cosecant. So now cosecant is one of our reciprocal ones. So I'm going to use this one right here, and I'm going to rewrite this as 1 over sine. Okay, so because I have a sine squared on top and a sine on the bottom, I can cancel out this sine with one of these. So it cancels out the squares. It just leaves us with 1 sine on top. And if we have 1 sine on top and 1 cosine on the bottom, this is sine over cosine tangent. So we can rewrite this as just tangent. And now we just have 1 trig function. And so that can be our answer. Okay. Let's go on to number 3. So for this one, we have cosecant squared times 1 minus cosine squared. So when I'm looking at this 1 minus cosine squared, this reminds me of one of my Pythagorean identities, this one right here. So I know that sine squared plus cosine squared equals 1. If I want to solve this so I have 1 minus cosine squared, what I'm going to do is subtract cosine squared from both sides. And this leaves me with sine squared equals 1 minus cosine squared. So because 1 minus cosine squared is the same thing as sine squared, I can actually replace this whole thing with sine squared because these two are the same thing. They're equivalent. Cosecant squared is a reciprocal, and cosecant is 1 over sine, so cosecant squared must be 1 over sine squared. And so when I multiply this across, the sine squared and the sine squared actually cancel each other out. Oh, this is an x. They multiply, and then when they multiply across, they cancel each other out, so we're just left with 1. Okay, next. So let's look at number 4. So we have sine times cosecant minus sine. So cosecant minus sine, there isn't an identity here that we could change it into. So we're going to distribute this first. So if we distribute this, we have sine x times cosecant x minus sine squared x, because sine times sine gives you sine squared. I'm going to rewrite cosecant. So cosecant is a reciprocal. It's this one, 1 over sine. And so this is sine over 1. And right here, the sine and the sine are going to cancel each other out, which just leaves us with 1 minus sine squared. And again, this is a squared, and there's a 1, so this reminds me of one of our Pythagorean identities. So right here, I have sine squared plus cosine squared equals 1. If I want it to be 1 minus sine, I would subtract sine squared from both sides, which gives us cosine squared equals 1 minus sine squared. So 1 minus sine squared is equivalent to cosine squared, so I can just rewrite this as cosine squared x. And that is one term by itself, so that could be my answer. Okay. So let's go on to one that's a little bit more complicated. So for number 5, let's start with this, because this one is easy to do. This is sine, and I'm going to replace cosecant with 1 over sine. So I already know this is probably going to cancel out. For this one right here, so I have a cotangent squared over cosecant plus 1. Because I have this cotangent squared, I'm already thinking about one of the Pythagorean identities, because those all have squares in them. If I were to replace cotangent with something, it would give me something with cosecant, which is what I want because there's a cosecant on the bottom of this. So because 1 plus cotangent squared equals cosecant, I'm going to solve so I can get the cotangent by itself. So I'm going to subtract 1 from both sides. That gives me cosecant squared minus 1. So I'm going to be replacing this cotangent squared with cosecant squared minus 1. And I still have cosecant plus 1 on the bottom. Okay. So now this is something. This one's tricky because we have to use an identity that we learned during the first unit. This is a squared. 1 is also a squared. So we're actually going to use difference of squares to factor this. So cosecant squared minus 1 squared, I can rewrite as cosecant minus 1, cosecant plus 1. And over here on this side, my sine over sine cancel each other out, so this is just leaving me with 1. As I can tell over here, my cosecant plus 1 are going to cancel each other out. So I'm just left with cosecant minus 1, and then I have this plus 1 over here. The minus 1 and the plus 1 are going to add up to 0, which just leaves us with cosecant. So that's one term, so that could be our final answer. Okay, for number 6, sine minus 1, sine plus 1. So this is not going to work with any of our identities, our Pythagorean identities, because there's no square. So even if this was a squared, you could replace this with cosine squared. But because it's not squared, it's just sine minus 1. We can't do that. So what we can do is distribute this or FOIL it. So sine times sine gives us sine squared. Sine times 1 just gives me 1 sine. Negative 1 times sine gives me negative sine. And then negative 1 times 1 gives me negative 1. My plus sign and my minus sign cancel each other out, so I'm left with sine squared minus 1. And so because this is squared, I can actually now use this identity right here. So I have sine squared plus cosine squared equals 1. And I want to solve for sine squared minus 1. So right now I have sine over here. I'm going to subtract 1 to get 1 on this side. So this is sine squared minus 1. I want to get the cosine on the other side. So I'm going to subtract cosine to get rid of this cosine. And that leaves me with sine squared minus 1 on this side. And that leaves me with a negative cosine squared over here. So sine squared minus 1 is equal to negative cosine. So I can replace sine squared minus 1 with negative cosine squared. And that could be my final answer because that's just one term.